Hello and welcome back to Calculus 3, the first half of 13.5. The rest will be taken care of tomorrow. So we have to discuss the line in space, which is the straight line that you know and love from 2D. Your 2D case was straight line y equal mx plus b, and the way to deal with the line, you had 2 points, let's say point A and point B. So what you did is you figure out the slope m, having yb minus ya divided by xb minus xa, and the slope was measuring the steepness of the line. Slope was measuring the steepness of the line. So that was your 2D. Now in 3D, we have to figure out the way to find the line in a different way, but it will have the pretty much same features. Still, 2 points are all you need in space to define a line. Now we're going to put this in the coordinate system. X, Y, Z. We are using the right-handed coordinate system. I'm going to draw a line, and we'll put 2 points, point P0 and the point P, and then we are going to use vectors to define those points. So this vector will be called vector R0, and the red vector is the vector R. All right, so now I am going to have another vector here, and we'll talk about this vector eventually. This is vector t times v. I'll come back to that and explain. All right, so what's happening over here? Well, I have my origin over here, which is 0, 0, 0. I have my point P, which is going to be x, y, z. That's the point P. Now P0 is x0, y0, z0 coordinates. And vector v. Vector v is any vector in a direction, right, that is on this P to P0, which is actually direction of the line. So any vector in that direction. It doesn't have to necessarily be exact one that we need, so whatever. We just need its direction, and then t is going to scale that. So if you look at these 3 vectors, you see that vector r, if you just use the basic addition, vector r is equal to the vector r0 plus the green vector tv. I hope you see that, because we learned that if you have two vectors that are head to tail like that, then the resultant stretches across. So you see that the blue vector is going into the green vector, so they are together creating vector R. That's the only configuration that you can draw from this diagram in terms of addition. So that's the equation that I have. Now vector R is the vector x, y, and z, because you subtract the coordinates. So vector R is x, y, z, because you subtract x minus 0, y minus 0, z minus 0 to get that vector. Vector R0 is vector x0, y0, z0, as again you subtract the coordinates. So when you subtract all of these coordinates, you get these vectors, and we're just going to define vector v to be some a, b, c, because we just need values there. Now when you plug all of these into the equation above, we get vector xyz is equal to vector x0, y0, z0 plus t times abc. And that is already equation of the line. But it's not as cool as we would like it to be. So we are going to come up with parametric set, which is what we use. X equals x0 plus at, y equals y0 plus bt, z equals z0 plus ct. This is the parametric set. 3 equations as a parametric set to describe one straight line in 3D. It's worth to mention that t is in between negative infinity and positive infinity. That's if you don't specify that t is in between infinity, it's understood, but you can come up with a line segment, right? If you look at this pen, this is a straight line, but it's a finite length, right? So this is a line in space, but it's finite length. So if you don't specify anything, we just assume it's infinite line. If you have endpoints, then it's a line segment, and we can actually compute the length and all of that good stuff. So let's find find the line between points 0, 3, and -2, and 1, 6, and 4. So find the line between 0, 3, -2, 1, 6, 4.
I'll ask her about it. Question.
Yes.
Is that one time interval to get from that point to?
So it's going to be no. This is going to be the line, infinite line. The next line we're going to do is a line segment, and then we're going to call it.
Well, are you asking us to find how are we supposed to find A, B, and C from this? A little bit confused.
Aha. Well, go back to the diagram you drew. You see that the 2 points that I'm giving you are P and P0?
Yeah.
So what's your vector V then?
Vector V is going to be between the two. The vector V.
Between those 2 points. So how do you find vector V?
Subtract the points, yeah.
You subtract these points to get vector. Very good. So 1 minus 0,
okay, yeah.
6 minus 3. Okay. So vector V is going to be the difference between these coordinates to come up with the vector. And then you have each one of the points as R0. And so pick one to be your fixed point, the P0, because you need to have them correctly assigned. You can assign them in any way, but you can't move the assignment once you pick. So if you pick this one to be P0, then this one is P. Your vector V is P0P, which is 1 minus 0, 6 minus 3, and 4 plus 2, which is 1, 3, 6. So V is 1, 3, 6. And then you have your x, y, z is 0, 3, negative 2, plus 1t, plus 3t, plus 6t. And then we just write the answer. X equals t, y equals 3 plus 3t, and z equals negative 2 plus 6t. And that will be the answer.
So your answer is in parametrics?
Yes, the line will have parametric always. The next problem is asking you to calculate the line segment. So over here, your t is between the previous problem, your t is between negative infinity and positive infinity. That line is infinite. The next question is asking about line segment. Now that means that your t will be in between some values, right? T1 and T2, let's say. So for line segment, you will have t between, I don't know, 2 and 7, whatever. So let's go and pick from homework. Line segment here, problem 28. It says the points are 1, 0, 1 and 0, negative 2, 1.
Don't we need the domain as well?
Why? You have the endpoints. So that will So when I subtract 0 minus 1, that's negative 1. Negative 2 minus 0, negative 2. And 1 minus 1 is 0. So I have that. And then I have my x, y, z. My fixed point 1, 0, 1. Minus 1t, minus 2t. And then plus 0t. And I write this as 1 minus t, y is equal to negative 2t, and z equals to 1. And now I have to figure out what are the values for t that will give me these points. So now I look at the first point and I look at the equations I have. For what t am I going to get this point? For 0. Because when t is equal to 0, 1 minus 0 is 1. Negative 2 times 0 is 0. And then the z coordinate is always 1. So we're good there. So that's that. Now, again, the next one is, for what value of t am I going to get the second point? 1. Good. Because 1 minus 1 is 0. Negative 2 times 1 is negative 2, and 1 is equal to 1. This skill will be important for our last chapter, when we have to do line integrals, and then we'll have to figure out the line segments and so on. Yes?
If that question was like on a test or something, will we be given an interval of time to find for? Because you could change around that equation so it would be the same, just in different time intervals. Couldn't you?
No, your equation is fixed because you have fixed 2 points. This is the equation of the line, it's unique.
The
Yeah,
line
but if
doesn't exist past the 2.
But if we cut that, say if we said 1 minus 1/2 t and then negative t, we could, just with restating that equation, we could say it exists from 0 to t. To t.
It's not going to go to those points.
It can't physically.
The points are defined in the problem, and so it doesn't
Yes.
exist past those points on either side.
No. He's saying that he can redefine these,
Yeah.
but you can't, because they will not go to these points. Only this set of equations goes to this point.
Can I ask you a question after? Because I don't want to take up
Sure.
time. Sorry.
All right. Another one? That's the best. Like, you're so funny. Yeah, I'm glad. I'm here to entertain and educate sometimes. All right, I'll see you tomorrow. We'll finish this tomorrow.